Okay, so this is an EasyEDA tutorial to help you turn the circuit board that we built early this week into a PCB, a printed circuit board that can be manufactured and soldered. This tutorial does assume that you have completed your breadboarded model and that it works and is tested. You'll definitely want to make sure that that is the case before you start on this. It also assumes that you have an EasyEDA account and that you have joined the CRT 399 Design Studio group. So that's going to give you access to the parts. It's also going to allow us to be able to share plans. And so if you've not done that, then you should go back to the software roundup document, and there's a little tutorial video on how to get access to the 399 group. Once you're signed in and you have joined the group, then what we're going to do is we're going to go ahead and create a new project. Okay, and we're going to change the owner to Fall 2020 Design Studio. So that's going to make sure that it's on a shared site for us. And the title is going to be Hack Help dash and then your name. Okay, and that's going to help distinguish all of our projects from each other. So I'm going to go ahead and click Save. Okay, and that's going to open up a new document for me where I can begin my work. So for title, we're going to come down here and we're going to call this Hack Help. For company, we're going to say CRT 399. And the drawn by, I'm just double clicking on these. I can type in Zane Cochran. Okay, and that would be your name. And so at this point, what we want to do is we want to kind of begin to go shopping for all of the components that we used on here. And one of the nice things about joining the group is that these are going to be kind of all conveniently located in one place. And so just kind of walk through, we've got our ESP32 Arduino, we've got an RGB LED, we've got two 10K resistors, we've got two push buttons, we've got a battery, and then a bunch of wires. So let's go see if we can find these over here on EasyEDA. So I'm going to go ahead and save. I'm just going to hit Command S or Control S, depending on what operating system you're on. And if I hit Shift F, that's going to take me into a place where I can look through my library of components. And so here you can get access to so many different, repositories of a lot of different components. But if you're on our workspace, you should be able to come down here and find a Fall 2020 Design Studio. And if you click that plus sign to open it and click All, you're going to see a lot of the components that we need here already. And so what we're going to do is we're going to click on this first one. This is our ESP32. And we're going to place, and we're going to find a nice little spot to put it. We'll put it maybe right there. We only want one, so don't double click. So if you want to get rid of this component, you can just hit Escape, and that'll make it go away. So we'll hit Shift F again. Here you can see that we have a 300 milliamp lithium polymer battery. So we're going to click on that as well. Okay, and we'll just drop that over here. Okay. Push buttons. This is good. So we need two of these. So we're going to place, and I'm going to place these just one there and one there. We're kind of spreading things out because we're going to be writing a lot of components to these. 10K resistor. Well, we know we need two of these, and I know that those are going to kind of go kind of close to the push buttons, and so I'm going to kind of put them in close proximity to those push buttons. Okay. And last thing we need is our RGB LED. Okay, so I'm going to kind of place that right about here. Okay, so we've got kind of all of our components on here, but the real tricky bit is, well, obviously finding out how to hook them up. And to do this, we can actually refer back to our board here, and that's going to tell us a lot about where things need to go. But let's kind of start at the beginning. The first thing that we need to do is we need to make sure that the ESP32, we're going to be drawing power and ground from it, and we want to make sure that it is hooked up appropriately. And so the way that we're going to do that is we've got these little flags over here. So this one here means it's a net flag for ground, which is good. And this is a net flag for VCC, or the positive side of our our circuit. And so I'm going to click on this. And for this case, we're actually going to be using the 3-volt line for our circuit here. And so I'm going to click that over here, and I'm going to come over and click on the ground flag. And I'm going to rotate this a little bit. I like it kind of when it's a little bit sideways. And I'm going to put that right by the ground and click. Okay, and I'm going to go ahead and rotate. Maybe not. That one's kind of being weird. Okay, so we've got these kind of in proximity, but we need to hook them up. Now, hooking things up, it can be easy to get into a hurry and kind of miss these connections. We don't want to do that. And so we can use our wire tool right here. And so you can either click on it here, or you can see that it's got a little helper. It says W, so you can hit W as well. And when I hover over a connection, you can see this little black dot that appears. And so I want to click that. And I want to make sure that I get a black dot for each connection. Sometimes you can get close but not actually connect it. And that's bad because then there won't be a real connection between the two. One thing that you also want to kind of avoid is you want to avoid kind of crossing over other endpoints. So for example, if I came here and I wanted to connect to ground, you'll see how it also like gives you a dot on 2 and 15. That means it's actually connected to all 3 of those pins. And we definitely don't want that. And so as you're kind of crossing paths, just make sure that you are avoiding any unwanted connections. And so I'm going to connect my ground. And that's good. So we've got our ESP32 hooked up to power. Now you will notice over here on our lithium polymer battery that it does not have any connection points. And that does seem strange. Why would we include that if we're not actually hooking it up to our in our circuit diagram that we're designing here? The reason why is because the way that our battery hooks up is it doesn't actually have any connections on the circuit board itself. The ESP32 already has a connector for it. You can see it kind of here on the board, but also in our diagram, you can see that it's represented here with this little plus and minus. And so what that means is we don't actually physically need to make a connection on the circuit board. We'll be doing that externally through these connector wires. But it's still important for us to have it in the diagram because when we design the board, we're going to need to keep the shape and size of this in mind so that we make sure that there's space for it on our board. So that being said, let's go ahead and move on to a component that is going to get hooked up. And we're going to look at our 5mm RGB LED. You'll notice that it's common cathode. And what common cathode means is that all of these red, green, and blue LED diodes all share a common ground. And so let's go ahead and bring in that ground. And so I can bring that close to here. And again, using my wiring tool, I can wire those 2 components together. So those are hooked up. But now we have to kind of figure out, well, where do we want the red, green, and blue to hook up? And for that, we can look over here. And on our circuit board, we used pins 4, 16, and 17 to hook this up. And so we're going to do the same thing here. And I'm going to kind of come over here on 4 and hook that up to this one and bring it across and hook it up here. And 17 comes across here. And you'll notice how I'm trying to keep my kind of wire spacing as consistent as possible. That just makes for a much easier kind of way to read these diagrams. And so it's pretty easy to see where things are hooked up. Now you might be concerned, you're like saying, well, I wired on mine, I hooked my red LED up to 4 and my blue LED up to 17. So what if it's backward? Well, and that's okay, because we could always go back into our software and just remap those LEDs to whichever pins that you plugged in. And so with this, it's going to keep our circuit pretty straightforward. And so in this case, it's okay, because we could always just go change our code to reflect these changes. Okay, so that leaves just a couple of small things left. We've got our push buttons to hook up. And so again, if we look over here, we can see that we've got a push button that is going over to a 10K resistor that goes to ground. Also on that, we have a wire that's taking us down to pin number 2 and pin number 15. And then we've got another wire that's taking us over to the positive, the VCC of the circuit. So again, we can do something pretty similar with that. I'm going to line these up just a little bit better. And I'm going to go ahead and hook up one side of my circuit to VCC. Okay, so I'm going to kind of come in here and say this side is going to be VCC, and we can wire that together. Making sure I get those confirmation of those little black dots. Okay, and we can see on the other side of the switch, you can see that the switch breaks right here in the center. On the other side of the switch, well, we want to go ahead and wire up this resistor. Okay, and on the other side of the resistor, we know that we need to go to ground. And so we'll put 2 little ground flags here, and we will hook them up. Okay. And now at this point, all we need to do is we need to wire them into the appropriate pins. And so with here, I can come across, and I can bring that all the way across and come down, and you see how it makes that junction right there with the resistor, and that's what we want. Okay, and for 15, I can come down. And again, I'd want to avoid doing something like this because you see how it's going to make an accidental connection there. So we want to avoid that. So we're going to come down. I'm going to come over the top and then come down. And to make these little bend points, you can just kind of click along the way, and that can add little bend points. And at this point, we have that connected up the way that it should be. So let's take a look at what we've done here and just kind of do a mental checklist to make sure that everything seems to be right. The first thing is do we have power going to our board? And we've got VCC and ground here, so that seems to be the case. We've accounted for our lithium polymer battery. Again, it's not electrically hooked up to any of this, but it will be when we actually plug it into the ESP32. We've got our common cathode RGB LED that's all hooked up to ground, and each of those LEDs is hooked up to its respective pins. And then we've got our push buttons, and we know that with push buttons, one side goes to VCC, the other side goes to ground through a 10K resistor, and then at the other side of those buttons, we've got those hooked up to 2 digital inputs, pins number 2 and 15. So this looks good. So let's go ahead and save this, and at this point, we'd have a completed circuit diagram, electric schematic, and it looks pretty organized. Again, anybody could look at this and sort of figure out what's going on. You want to avoid kind of having too much going on or too many wires crossing because that just gets confusing to read. At this point then, what we want to do is we want to turn this into a PCB. And so let's go ahead and work on that. So we're going to go to Design, and we're going to say Convert to PCB. And you'll need to save this before, so just go ahead and make sure you hit Control-S or Command-S and Convert to PCB. This is going to warn you that you've got some unfinished nets. What that means is it says, hey, there's some pins over here that didn't get connected, and that's okay. We don't want every single pin to be connected on our boards, and so it's okay to say, no, keep going. We know what we're doing. Okay. At this point, it's going to create a new PCB for us. We do want the units to be in millimeters. That's going to help us. And we can go ahead and say, yeah, make a rectangular board outline. And at this point, we want to kind of go searching for all of our stuff. Okay. Now, I like to make a couple of changes here. You can see that it says grid size is 2.5 millimeters. I'm going to change that to 10 for now. Just makes it a little bit easier to work with. And as I'm getting kind of components into place, I'm going to say, give me a snap size of 1. And that means that it's going to kind of, lock itself in 1 millimeter increments. And we'll play around with this grid size and snap size a lot. You do want to double check that this routing conflict is set to block. This is going to help you prevent, it's going to help prevent mistakes from happening of just running wires on top of each other. And so our goal here is to try to create what we call just the smallest footprint that we can, because this is going to be a handheld device, and we don't want this to take up just huge amounts of room. And so for that, we're actually going to get rid of this, this outline that it made for us. So you can do it. It's this pink outline. We can go ahead and click on that and click Delete. And we'll draw that back in later, but we kind of want to start playing with these components and figure out kind of what's the smallest footprint that they can take. So I'm going to show you a way that I figured out, but you're welcome to try out your own configurations as well. You can even see if maybe you can get it to be even smaller than mine. And so I'm going to take my ESP32. That seems to be the biggest component here. And I'm actually going to say, go ahead and put that on the bottom layer. And so I've got that selected, and with it selected, you can choose layer. It was on the top, but I'm going to say, go ahead and come over here on the bottom layer. We're going to kind of have that be on the back side of the board, and we're going to put these other components on the front side of the board. We also sort of have to figure out this battery, where could it go? And just based on the geometry of the ESP32, I'm actually going to say that there's actually a little bit of room when we put it on the boards. There's actually a little bit of room for it to go underneath that on the back side of the board. Okay, so I'm going to place that battery as well. Okay, I'm going to rotate it. Again, I can select it and hit R for rotate. And I'm going to drop it to the back layer as well. And I want to rotate it so that this little kind of plus minus here, that's kind of the side that is going to be where the wire is going to be coming out, is oriented toward the top. Okay, and I also want to make sure that I'm kind of thinking this through correctly. So if we kind of see that we've got that short row of pins there and the long row of pins there, if we look over here at our board, we can see we've got the long row of pins and the short row of pins. Again, you have to kind of think about this as if you're kind of looking through the board. We want to make sure that we take into consideration where the USB connector is. We're going to want access to that so we can recharge the battery as well as be able to connect to it and program it. We want to keep in mind where this is because we want to make sure that our battery is going to be oriented to where it can plug into that. And so with it in this orientation, the USB is down here near the bottom. So we'll just kind of keep that in mind. Okay, so I'm going to take my battery and I'm actually going to place it pretty much right down the middle. And that's going to kind of, again, just create a visual indicator to me of where that battery is going to ultimately reside. Okay, now at this point, we have to start thinking about not just kind of where kind of electrically it makes sense to kind of put our buttons and our LEDs, but also ergonomically where it makes sense to put these things. So someone's going to be using this, they're going to be holding it in their hand. And so if like you've got like a button over here and a button over here, that's weird. Like that's not going to be, you know, conducive to them being able to use it. And so we're going to have to navigate between kind of the physical constraints of making this as small as we can, but also the practical constraints of the person who's going to be using it. And so the way that I think about maybe it working is maybe we'll have the LED at the top, and we'll have a kind of a push button here in the center, and maybe another one kind of right next to it. And you can kind of see, well, maybe that's going to be a little bit weird to get all these things hooked up, but we're gonna do our best and we're gonna try. Okay, I want to make sure that these are relatively centered. So, and we also have these resistors that we need to take care of. Now with these, ideally we want the resistors to be kind of close to the things that they're controlling. And it looks like this resistor kind of wants to go over by this button, and that's good. So I'm going to kind of rotate it around and bring it in nice and close to it. Okay, and rotate that around, and again, just bring it in nice and close to it. Now at this point, again, we've got to figure out, well, what are all these connections that we want to make? And if we zoom in, we can see we've got several to make. And we're going to make our job easy. We're going to actually ignore all of the ground and VCC connections for now. We're actually going to do those last. And so as we kind of are zooming around, we want to make any connection that's like, this U135. We want to go ahead and make those. But we're going to avoid anything that says, VCC or ground. Those are all going to come later on. Okay. So I'm going to look for kind of some kind of short, easy connections to make. So again, I'll hit my little wire tool. And at this point, it can be helpful to change your snap size. So as I'm kind of making these connections, that snap size of 1 millimeter is going to make for some kind of chunky connections. And so we're going to change that to 0.1 for now. And that's going to allow kind of some smoother connections to take place. So I made that connection there. I'm going to come over and make this connection. And again, at this point, we're just kind of looking for the easy ones. And so you can kind of click and drag around. And I'm going to say, okay, let's look in here. Let's see, that's a VCC. Okay, it looks like I've got a UI36 here. Let's go ahead and see where that goes. Okay, so that's coming right down here. And so I've got a couple different ways that I could come over here. I'm going to cut through here and kind of just leave some more space. I think I've got some more stuff that's going to come down here. So I'm going to come through here. And we don't want to do 90-degree angles, so I could come down like that and just come straight across, but 90-degree angles are actually bad for circuit design. And so I just want to keep things going nice and smooth. You can see there's no 90-degree angles in this circuit. Okay, so let's see if we've got another thing that can be made here. So I'm going to come down here. Okay, and you can see as I'm trying to, like, go over the top of something that I shouldn't, it prevents me from doing that. So let's come down here. Oh, then I've got a connection nice close by. Okay, so again, just avoiding those 90-degree angles. And right now, all of these traces, these little copper wires that are being made on top of the board. If we get super desperate, we can put some on the bottom, and that will be okay. But we're going to try to do as many on the top as we possibly can. Okay, let's look at this LED. And this LED, it looks a little kind of twisted up. And so I'm actually going to kind of rotate it. I'm going to bring this label over here and click rotate a couple times to kind of make it right side up. But you can see now that those wires are kind of untwisted now. And that's going to make routing them just a little bit easier. Okay, so I'm going to start with this one. I'm going to hit my little wire tool. And I'm going to come across. Okay, make that connection. Okay, come across. Make that connection. And come across. And make that connection. Okay, so we're making some pretty good progress here. Let's take a look at kind of the remaining connections that we have here. Let's see, so that's a ground connection. I see more ground connections. Okay. And let's see, yeah, looks like we're getting a lot of them. And if we want to make sure, we can actually kind of track the progress of how we're doing. So I'm going to go ahead and click Save. It's always good to do that. But if I click over here on Design Manager, and I hit this little refresh on nets, you can see it says 38 out of 40. It says you made all of these connections, but the only ones that aren't connected are ground and VC. And that's good. We wanted to save those to the very end, and so we're in good shape so far. So we just got a few more connections to make. But what we're going to do in order to make these connections is we're going to do what are called power and ground planes. And we're going to turn essentially the entire side of each of the board into just a big chunk of copper that's either electrically charged negative or electrically charged positive. And that means we actually need to draw our board outline here. So to do that, what we can do is we can come over to our layers and objects, and we can go over to board outline, and I'm going to click right on that pink color, and that's going to select that for me. And at this point, I want to change my snap size back. I'm going to show you kind of what happens if you don't. So if we draw our board outline, I can kind of take some really kind of small kind of chunks in here, and I sort of want to be able to keep that a little bit more fine-grained. So for this board outline, I'm going to say, I'm going to do something like maybe 1 millimeter. And that's going to give me something a little bit better that I can work with. Okay. Now at this point, we want to make sure that we get the entire board in our picture. And what I'm also going to keep in mind is that we're going to add some mounting holes to this because we want to be able to screw our board into our enclosure that we're going to design. And so I want to leave this end kind of relatively narrow because we're going to need to be able to plug the USB in. And so I'm going to actually start a little bit wide. Okay, and I'm going to come across and I'm just kind of clicking once and come up this way. Okay, and I'm going to do one final left click here, and then I'm going to right click to stop drawing on the board. Okay. So, and at this point, it's like we got to ask ourselves, okay, is this going to work? Is there enough room for everything? And this looks pretty okay. And so at this point then, as I mentioned, we want to add some mounting holes. Okay. And so we're going to come in and we're going to come up to this corner, and we want to be really thoughtful about making sure that they go in the same place each time. So I'm coming in one step, two step, again, one step, two step from each side. That's going to be 2 millimeters from each side to make sure that those are going in consistently. That's going to make designing an enclosure for the board a lot easier later on. Okay, so again, I'm going to save up. So now that I have my board outline, I can finish up all these connections with the power and ground planes, and then we'll add some graphics to it, and we'll see what we've got. So what I'm going to do is I'm going to make sure that I'm going to go back to my top layer. I'm going to click on the red. And I'm going to come over to this little dashed area. This is called the copper area. And I'm going to click on that. And for the net, I want this top area to be VCC. So I'm going to go click VCC and click OK. And I'm going to click on each of the four corners. So 1, 2, 3, 4. I'm going to come back up and right click. Okay, and you can see it actually fills this entire area in with copper. I can go over my design manager. If I expand it right here, and if I hit that, it says, yep, so VCC is taken care of. That's good, so all we have left is our ground. Okay, so what we can do is we can come over here and click on the bottom layer. We'll click on that copper fill tool again, and this time we want that to be our ground. So we'll click ground and click OK, and we'll repeat the same process. Click once, twice, 3 times, 4 times, and then come up to the very top and right click. Okay, it's going to fill that area in with that copper for the ground. Okay, so again, we can check that by clicking on this little expansion, refresh this, and we say we've got 40 out of 40 nets, and that's good. So now we're going to run DRC. DRC stands for Design Rules Check, and that just makes sure that you didn't make any mistakes that would make this thing unmanufacturable. It says that there's 0 errors, which is good. And so I'm going to click Save. And at this point, we have a completed board. So we're going to do a couple things with that. So first of all, we want to take a look at it. And so we're going to go to View and 3D View. Okay. And here we can sort of check it out. And so far, it looks pretty good. But I think we're missing a thing or two. And so we not added any text to describe kind of what this is. So I mean, it looks pretty good. We can change the color of the board and make it all fancy. But we want to kind of finish that up and make it really shine. So let's go down and we're going to go to our text tool. And with our text, I've actually made a mistake here. I'm going to hit Escape. We don't want to do text on the top layer. We want to do text on the top silk layer. And this is a layer of ink that they'll put on the board. And so we want that to be done in ink. So I'm going to call this the Hack Help version 1.0. Okay. And I want to kind of put it somewhere where it'll be pretty noticeable. So maybe right here. And again, you can just rotate by hitting R. And I'm going to do another one. I'm going to say, oh, maybe even number that 1.1 for me. That's hilarious. I'm going to change this to my name, so I can take credit for designing. And you'll use your name for your design. Okay. And I'm going to rotate that, and I'm going to put mine on the other side of the board. Again, you can choose wherever you'd like yours. Okay, so once you get to this point, what I would like for you to do is to go into that view, go to that 3D view, and capture a screenshot of your design, both front and back. So grab 2 kind of rendered views, and if you want to be fancy, you can do one at a kind of more oblique angle. And then I also want you to take a screenshot of this design as well as a screenshot of your circuit, and that's going to be for your documentation. So screenshots of all of your work so that we can see how you've come. But as soon as you've gotten to this point, you should be able to see in the projects that you have kind of finished up your project, and it'll be available for other people to see. And that's it.